Today we will study about the stationary waves. So what are the stationary waves? When the two waves of same frequency and same wavelength but moving in the opposite direction superimpose on each other, the waves so produced are called stationary waves. So these are the stationary waves. This is moving in this direction and this is moving in this direction. Okay, same wavelength and same amplitude and same frequency. So these are called stationary waves. So we will study its various cases. So first case, the stationary waves produced in a string fixed at both ends. Okay, this way. So for example, this is a string fixed at both ends. Okay, so we know that any wave moving from left to right have equation y is equal to r sine 2 pi upon lambda into vt minus x. Okay, this is the equation of wave which is moving from left to right and origin is o dash. Okay, but in this case we will shift the origin to o dash. The origin is shifted to o dash. Then equation होगी y dash is equal to, or y we can write here r sine 2 pi upon lambda into vt plus x. Okay, this is the equation. Origin is only shifted just to take here positive, otherwise there is no any other rule. So y is equal to r sine 2 pi upon lambda vt plus x. Okay, after reflection, you know that after reflection what will happen? After reflection, you must be knowing that the phase change of pi takes place after reflection and the wave will move from right to left. So the equation will be minus r sine 2 pi upon lambda vt minus x. This is equation number 2. Okay. Now after when the waves superimpose on each other to produce the stationary waves. So I can write here the final displacement will be y double dash and it is equal to y dash plus y plus y dash. Okay, according to the principle of superposition of wave, according to superposition principle. Okay, so we will add here y double dash is equal to r sine 2 pi upon lambda vt plus x and plus means यहाँ पे minus हो जाएगा. So it is r sine 2 pi upon lambda vt minus x. Okay, so we will apply a rule here, and what is that rule? Sine c plus sine d, sorry, minus d, and it is 2 cos c plus d upon 2 and sine c minus d upon 2. So we will find here. So we will apply this rule in this equation. Y double dash will be equal to 2 r cos 2 pi upon lambda. Now when they are added, now x will be cancelled and we will get here vt. Okay, because it is plus, So Vt plus x, Vt minus x, x will be cancelled, and 2Vt upon 2, so it will be there, and sine, now Vt means c minus t, c minus t, it will become minus and it will become plus, means we will have 2 pi upon lambda into x. So this is your final equation. Now we will find its amplitude. So this is the, now in this equation it will be taken as amplitude, means y double dash is equal to a cos 2 pi upon lambda into Vt. Here we have taken here a, and what is a? A is equal to 2r sine 2 pi upon lambda into x. Okay. Now we will study the variation in amplitude by putting the value of x. So it is a case of two waves which are moving in the opposite direction. So it is clear that at x is equal to 0 or x is equal to L at both ends, this is very important. So if you see the figure, then x is equal to 0 and at x is equal to L, means complete length of the wire. Both at the both ends there will be amplitude will be equal to 0. So this is very important. So when we put here L, then A will be equal to, this implies that 0 is equal to sine 2 pi upon lambda into L. At x is equal to L and x is equal to 0, amplitude is 0. Why? Because they are fixed at the both ends. So now you must be knowing at what angles the angle is 0, and you know that at 0, and if you find the sine wave, you must be knowing sine wave moves like this. This is very important to understand. So at 0, this is pi by 2, this is pi, and you know that at pi it is again equal to 0, 3 pi by 2, and this is 2 pi. So you are finding 0, pi, 2 pi, 0, pi, 2 pi, 3 pi. In this way, at these angles the amplitude is 0. So it is clear that 0 is equal to sine 2 pi upon lambda into L, and the value of the angles will be equal to, means 2 pi upon lambda into L will be equal to n into pi. Why? Because, and what is the value of n? 0, 1, 2, 3, so on up to n. Because at these angles the angle will be equal to 0. So we will find here the pi gets cancelled with the pi, and we are left with L is equal to n lambda, L will be equal to n lambda upon 2. So this is your condition. ये आपकी condition बन गई है. So at L will be equal to n, pi से pi cancel हो जाएगा, L will be equal to n lambda upon 2. So we will find its various nodes. So various nodes or various modes of vibration. So how can we find this various modes of vibration? So at n is equal to 1, this is called first mode of vibration. First mode So this is the first mode of vibration. How can we find it? Now putting the value of n, now it is will be equal to L is equal to lambda by 2. This is very important. Now it means that at complete length, this is a complete length L, and the total wave is half, means in this way. This is the incident wave. Now after reflection it will move like this, in this way. Okay, half wave because full wave is this, in this way. So half wave because in the complete length L it is having lambda by 2, means this is the half wave. So in this way we can find here that the complete length consists of half wave, and after reflection it will move like this. So but in terms of frequency, we know that lambda is equal to V is equal to lambda into nu. Now we will put here nu 1 because it's the first mode. So lambda can be made equal to V upon nu 1. This implies that L is equal to V upon nu 1, or we can say that nu 1 upon 2, nu 1 is equal to V upon 2L. So this is the first mode of vibration. This is also called fundamental frequency. Fundamental frequency. Nu 1, fundamental frequency. And you are finding here, these are called the nodes and these are called the antinodes, where the displacement is maximum. So in the fundamental frequency, you can see nodes equal to 2 and antinodes is equal to 1. So this is very important. Now for the second mode of vibration. Second mode of vibration means here you will put n is equal to 2 in the basic equation. And what was the basic equation? L is equal to n lambda upon 2. So by putting n is equal to 2, you can find here L is equal to lambda. Means now the length will consist of a complete wavelength. So diagrammatically I can show here. This is the string fixed at both ends. Now complete wave. Complete wave means in this way. This is the incident wave and this is the reflected wave to produce the. Now again I will put the V is equal to lambda into nu 2. So L is equal to, so in place of lambda I can put here V upon nu 2. This implies that nu 2 is equal to V upon L. So now this is the second mode of vibration, and it is clear that now it consists of how many nodes? Nodes are 1, 2, 3 and antinodes. Antinodes equal to 1 and 2. There are 2. Okay. So this is the second mode of vibration. And if you compare it with the this first mode, then you find there nu 2 is equal to now it is clear that nu 2 is equal to, now if you put here 1 by 2, then it will become means nu 2 is equal to, so it is clear that nu 2 is equal to 2 into nu 1. Okay. So in the third mode of vibration, third mode of vibration means we will put n is equal to 3 in this basic equation, which is this. So L is equal to 3 lambda upon 2. So it is clear that in the third mode of vibration, the complete length will have 1.5 wavelength. Means I can write here, this is the string and this is the complete length. Now means 1.5. What will be this? This is complete 1 and this is half, in this way. 1.5 means we will write here in this way. This will have 1.5 wavelength and this is after reflection. So in this way you can find it right here, and this implies that V is equal to lambda into nu 3. So we will put here L is equal to 3 in place of L lambda I can write here V upon nu 3. This implies that nu 3 is equal to 3V upon L. And sorry, 2 is also here, 2L. So it is clear that nu 3 is equal to 3 into nu 1. So this is the third mode of operation, and it will have nodes. How many nodes are there? Nodes equal to 1, 2, 3, 4, and antinodes equal to 1, 2, 3, 3. So these are the modes of vibration, and we can write here, if we find the ratio of nu is to nu 2 is to nu 3 will be equal to 1 is to 2 is to 3. So this is the case when the string is fixed at both ends. Thank you very much.